let a equal to r minus 3 and b equal to r minus 1, then consider a function from set a to b such that fx equal to x minus 2 or x minus 3 is f11 and on 2, and justify your answer. Okay. So let us first check 1, 1. Let x1 and x2 are two numbers, two elements in set A, such that fx1 equal to fx2. Now what is fx equal to? X minus 2 or x minus 3. So fx1 will be x1 minus 2 over x1 minus 3. And fx2 will be x2 minus 2 over x3 minus 3. And now simplify. So you cross multiply x1 minus 2 into x2 minus 3 equal to x1 minus 3 into x2 minus 2. Work it out. It will be x1 x2 minus 3x1 minus 2x2 plus 6 equal to x1 x2 minus 2x1 minus 3x2 plus 6. x1, x2 and 6 cancels, and you take the terms on one side, so take 3x2 on the left, 3x2 minus 2x2, take 3x1 on the right, 3x1 minus 2x1. So immediately you get x2 equal to x1 or x1 equal to x2. So what do you prove? That fx1 equal to fx2 implies x1 equal to x2, and hence the given function f is 1, 1. And now let us check onto. To check onto, for onto, you know, we are defined fx is equal to, fx is defined as x minus 2 over x minus 3 equal to 1, where y is an element in set B. Let me see if I could find out a value of x for which its image will be y. From here you work out the value of x. Cross multiply, what do you get? X minus 2 equal to y times x minus 3, or x minus 2 equal to xy minus 3y. And from here you further simplify, you get x is equal to 3y minus 2 over y minus 1, which is very much a number in the domain of the given function. So to each y in the codomain or set B, we can find out there is a number x equal to 3y minus 2 over y minus 1, such that fx, that is f of 3y minus 2 over y minus 1 equal to y, it can be verified. And hence the function f is onto. Already we have proved it is 1, 1. So the given function f is 1, 1 and onto. Now we are given a function f from set of real numbers to the real number, fx equal to x4. We have to check whether it is 1, 1 or onto, and then accordingly we can have the choice out of the 4. The 4 choices given are A, B, C, D. So we'll select out of A, B, C, D later. Now to check 1, 1. Let x1 and x2 are any two real numbers such that fx1 equal to fx2. That is x1 to the power 4 equal to x2 to the power 4. So can you find out a number, two different numbers whose fourth powers are same? it is as good as saying for x square. For example, if you find out f1, what is f1? 1 to the power 4, that is 1. And what is f of minus 1? F of minus 1 is minus 1 to the power 4, that is also 1. So we find, instead if I take an example, that f of 1 equal to f of minus 1 equal to 1. But 1 is not equal to negative 1. And hence the function f is not 1, 1. And now to check onto fx equal to x to the power 4 equal to y. Let me take the value of y in the codomain, any real number, say negative 1. So then what will be the value of x, the pre-image? It will be negative 1 to the power 1 by 4, fourth root of negative 1. Can you work out fourth root of negative 1? That is a different issue, you can work out or not. But there is no real number whose fourth power is negative 1. It does not belong to real number. That means negative 1 which belong to codomain, the real number, set of real number or codomain, does not have any pre-image in the domain, in the given set domain, and hence it is not onto. Earlier we have proved it is not 1, 1. So we can say it is neither 1, 1 nor onto. Which choice is this? Neither 1, 1 nor onto? Obviously the last choice, that is the D part, it is neither 1, 1 nor onto. Now next is we have to check the function from set of real number to real number defined as fx equal to 3x, whether it is, we have to check mainly whether it is 1, 1 onto or not, and there are 4 choices. Obviously according to 1, 1 onto we can check. Okay, so fx is equal to 3x. Check 1, 1. So let x1 and x2 are any two real numbers such that fx1 equal to fx2. That means 3x1 equal to 3x2. Clearly dividing both sides by 3, x1 equal to x2. So fx1 equal to fx2 implies x1 equal to x2. Clearly f is a 1, 1 function. F is 1, 1 function. And now again to check onto fx equal to 3x equal to y, let a real number in the codomain. And what is the value of x? Then y by 3. Hence, to each real number y in the codomain, we can have a value of x is equal to y by 3, such that f of y by 3, because what is the definition of fx? 3x, so it is f of y by 3 will be 3 times y by 3, that is y. So to each value of y we can work out its pre-image as y by 3, such that the image of y by 3 is y, and hence the given function f is onto. So the present function f is 1, 1 onto. You just check which choice is this. Do you find it is the first choice, A?